This is a recording of the February 20th co-social of the NMRA-PCR Coast Division. So can everybody see, did that come through?
Yes, sir.
Yep.
Cool. So next week, or actually not next week, on the March 6th, I should have put on here March 6th, so I blew that. Frank is going to go through the layout that he and Mike built for the California State Railroad Museum NMRA exhibit. He's going to go through what they built, how they built it, kind of why they built it. It's built to demonstrate modeling techniques, so part of the layout is actually kind of in a more unfinished state. And it's used mainly using commercial materials, trying to show how easy it is to actually create a layout. So we'll be doing that.
Phil, this is Frank. Mike's going to be on that call too.
Okay, Mike's going to be on too. Excellent, excellent.
So I've got that arranged. So we'll have to talk about how we get both of us able to talk and stuff at the same time.
Yeah, we'll just leave. What we'll do is we'll just leave the voice tracking on. And we'll just present, as long as everybody else mutes, I'll just mute everybody else. And that way it'll just track to you guys as you talk.
Okay.
By the way, that's one thing, just as a side, I'll wait till the end of this, I'll tell everyone. So that'll be on the 20th. And then also, I put in, by the way, the things on the convention. We'll also be doing our election on the 20th. On March 6th, I've got my dates wrong, on March 6th. So what we'll do is we'll do our election as the first item of business that day. The good content's obviously Frank and Mike. I will send out an email probably later today that is a vote by mail email. And so anyone who gets that email, the instructions will be to basically forward it or reply to Dave Connery with your vote. So if you want to vote by mail, you can do that. If you're planning on coming on the 6th, prefer just to do it vote then. If anyone wants to do any additional nominations today, I can put them on the list. Write-in candidates and nomination will be accepted. These are the current nominated candidates. So hopefully we'll be able to do that very quickly next week. So that's basically it as far as what I had. So today our focus is really just sharing what you're modeling and kind of talking about it. We really don't have a formal agenda today. So I will kind of throw it open to anyone. Bob Moore sent me some pictures of a gate he's been building. So he'd like to talk about that. But if anyone else has anything first, we can go with that, or we can jump over to Bob.
I didn't send you something, but give me a chance. I've got a little presentation, but after Bob, I'll be happy to.
So I'm going to share some slides for Bob, and we have not gone through these yet. So basically, don't get angry if it doesn't go very well planned. Okay, so I'm going to share, and then I'm going to throw it over to Bob. So
well,
Bob,
am I on?
You are on. We can hear you, and I think everyone can see the slides. So we're starting with that. Well, you can see them. So,
okay. I guess just a few preliminary comments. One about apologizing for the chaos of the presentation. The guys need to know, no, this is my usual thing. This is the only way I present. We go in the middle, and then we go to the beginning, and then we slide around to the end, and then we go back to in between the middle and the beginning. I also want to just sort of give a shout out to all the guys that have helped me on my layout. I have been some 14 years getting introduced into the hobby, and those guys know who they are. And the biggest one actually to Dave Parks, who sort of introduced me to most of these fools. Okay, looking at slide number 1, that shows the blank space. Well, okay, I guess I got to tell you guys where it is since we got multiple photos here. on my screen, it's the lower left corner. You'll see a door that I cut in half to make it a Dutch door. Yeah, back to that one. Okay, lower left corner of that first one there, Phil. And anyway, though, there's several that you just sort of observe. They become important a little later. One is that there's an electrical box in the corner. And with apologies to Dave Connery, all of your advice about, thinking things through and so forth and so on came late. That electrical box I discovered, there's code for the clearance they want you to have in front of an electrical box. And it's something like 30 inches by 17 feet. It's crazy. But for this box, it only services my train room. So as far as I'm concerned, the city building inspectors can kiss off. Okay, look at the top of the same group of pictures. You'll see my upper trackboard shelf. It's got 2 white cans on it. Back to, Dave's advice and whatnot, I built my upper shelf before building the lower one. And I know that that's backwards, but these guys I work with, I think they did this to me on purpose, but that's another story. In any event, though, I have some, I think it's 22 inches between shelves. And the issue with building this lower shelf is that whether you see the white cans, that's a lift out. After I got it put in, got it all set up, wired, functioning, and so forth and so on, doing something, I took it out, and the issue was, where do I set this silly thing while I'm doing something else? So with regard to the lower one that I'm working on, I decided that, no, I got to have something that'll stay in place. In the center photograph where you can see the yellow tape that says caution, that's showing me building out the stationary support for the bridge, and the wood that you see that's vertical coming up from that black computer desk down on the floor, that is some wood that I decided that I would keep, but in a different than you see it here, because it helps to stabilize this stationary board to hold the hinged gate. And then the picture you see on the lower right is where I'm starting to build out from the hole that's in the wall to that plate in front of the electrical box. And here, once again, I could see the problem, but I didn't recognize it. I wasn't thinking that when I built this, I needed to have this support assembly removable just in case the building inspectors came back. Okay, let's go on to the next one, Phil. Okay. Well, we're gonna at some point come back to that first one when we get to the next.
You want to jump ahead? You want to jump ahead or?
Yeah, jump ahead one, and then we'll come back to this one.
Okay.
Not included in that first group of photos is the upper left where you see the blue level. You can see how I'm building out that stationary plate from the wall. I've put a plate, a plywood plate essentially, against the wall, and it's screwed to the two 2x4s that frame the doorway, so that it's got sort of a really, the beginning of a pretty solid anchor there. And the level that you see there on that thing is giving me some sense of where a line will go back to the hole in the wall, but we'll need to get to that first. Okay, let's go back to the group number 2, Phil. Okay, in the photo on the left where you see the yellow and blue tape, the blue tape shows you the vertical hinges that I use to swing my gate out of the way. And we'll see a bigger photo of it later. But just sort of take a note of where you see the yellow tape with the arrow. That's pointing to stop when the gate comes back around so that it is in line with where the connect with Winchester, which is on the other side. Winchester will be part of the layout. The photo you see on the right shows the gate with the two hinges, and you see the red clamp holding my homemade triangle. The guys in my train gang, they'll tell you that I'm very frugal. So, I mean, I know you can buy squares and things like that, but if you got junk plywood lying around, this triangle you see here is incredibly handy because it has holes in it that allow me to clamp it to something, and I get an angle that's, you know, perpendicular to the support. But anyway, do you see how the gate is swung back closed? I have not put the track board on yet. Okay, let's go to the next one there, Phil. Okay. Yeah, okay. Starting with the photo you see on the right, the gate is, the bridge itself is actually now attached to the plate. Well, let me say, looking at the photo that's on the left where you can see the two clamps, you see the bridge is hinged and it's got a horizontal hinge as opposed to the vertical hinges that hold the doorway. And the gate is tilted up, and it's sort of starting to tell me what my problems will be with getting electrical contacts. Power will be coming in through that hole you see in the wall to the bridge, and Winchester will be on the side that you see where the blue clamps and the yellow clamps are, yellow clamp. In any event though, the bridge tilted up there, and that tilt is proven to be an issue that I haven't resolved yet, and we'll talk about it. The photo that's on the right is just another view of the same thing. Disregard all the junk you see. I'm also a tool junkie, and if I see tools, I gotta have them. All right, let's go to the next one, Phil. All right, these arrows tell you how I want to talk about what's happening here. Going back to the photo that's in the upper left, which we actually looked at another version of it on the other side. The blue clamps, in the corner, you see the blue clamps and that yellow squeezer clamp. That's the Winchester side. And the photo that's immediately below that, that's shown that the gate has now been actually rotated toward the camera and is starting to lower down to get to the photo that's in the upper right. And that shows the bridge gate completely out the way. And the bottom one, and Philip, yeah, hopefully you guys, I'm gonna move my photos a little bit out of blocking my view. That you can see there now, the bridge is completely out of the way. However, the bridge does not have any superstructure on it yet. In a delirious daydream, really, I've decided that I want to fashion this bridge to look like the Oregon City Bridge in Oregon, because I like the Oregon City Bridge. And there's no bridge leading into Winchester, West Virginia, but that's too bad. You'll have one on my layout. Okay, let's go to the next one, Phil. Okay, here we start to see, well, the photo on the left is just showing you what my problem area looks like. The three photos on the right is where I'm trying to sort of document how high will the track board be on the bridge itself above that cordovan wood that the red ruler is against in the back. Now that cordovan plywood, that's the permanent base of this bridge assembly. And when the bridge is tilted up, that edge you see closest to the ruler begins to tip down because the hinge is set some 3 inches away from the end of the bridge itself. That's one of the problems with how do I get electricity coming from our right to the bridge. And Phil, now I don't know whether the next group of photos will be a part of this grouping. Yes, it will be. Okay, good show. The photo, once again, that you see in the upper left, that is my connection point. In the middle photo, you can see what the track will look like eventually when the bridge is somewhat done. And I'm thinking of having 3 rails on the bridge itself, because when you get into Winchester on the prototype was essentially a stub-ended branch line. And in the town itself, I don't know where they switched cars, because when the train went through, it could deliver goods to warehouses on both sides of the railroad. And I don't know how they handle that, but that's another story. Going back to the photo that's on the upper left, you see some blue tape running up and down and the yellow tape running up and down. That's a possible location for contacts. The contacts could be vertical, but in another photo that we'll get to, I also took that tape and I put it on in a horizontal fashion. And just another little shout out to these presentations. One of the advantages that I'm having in just working my way through this bridge, my train guys will tell you that I have a tendency to overthink everything, but I kind of like that. I realize that my thinker is in decline, and that's okay. That's okay. But in any event, though, in doing the presentation, I get to see, well, okay, this is what my problem looks like to somebody who's not familiar with my layout. And I start to see alternatives. And this vertical versus horizontal possibility for the contact points is helping me figure that out. Going to the photo that's on the lower right, we have the same view, but now we're on the side of the bridge that the power will come from. And in the very bottommost part of that, you see a little black electrical connection box. And I just put that there just to say, okay, my wires come to this point, and it gives me a connection point to get power over to the bridge itself. Bill, let's go to the next group of photos.
I think that's the last of them there. So if it's going to be back here and something, if there's another photo, it's going to be back in here.
Oh, okay. I sent you another group and they weren't labeled. They just said JMP.
Okay, I'll have to go look for those.
Oh, okay.
Hang on. I'm going to
Sure.
stop sharing for a second. Why don't we go? Anyone wants to, we can have a comment on where we are. I guess my question, I had 2 questions looking at, because I did a similar thing at the club in Pleasanton, cut out a spline road bed and put a bridge in. And because it was a spline road bed that was permanent, they had run for the 2 tracks, the track power right along under the road bed.
Yeah.
And so by cutting the bridge in, clearly you cut that. And what I ended up doing was I basically connected on both sides and looped physically around the opening with the wire. and then ran just into the bridge from one side. So the power doesn't flow through the bridge. The power to the other side goes around the bridge, and the only thing that feeds in are wires to feed the power on the bridge itself. So I'd be interested about why you felt you had to have contacts on both sides. And I'll go look for the email then while you talk to that.
Okay. Well, let me just say that that's the situation. That was the solution I used for the power that's on the upper track board, because the upper track board is actually my double track main, and it is also my staging area, which is a through staging area. That is, you come in, well, from either end. One end of the staging area is considered Brunswick, Maryland. The other end of the staging area is considered Cumberland. And from either of those two ends, you can go eastbound or westbound, and you'll go completely around the upper track board. And I have takeoffs at a few places to go to branch lines, but that's another story. In any event though, so for the upper one, I also have power that goes up over that door and then continues, because you got to get the train out. And then I also have contacts up there to put power on the bridge. And I didn't think of that last thing that you used at the Pleasanton layout, which was I didn't need to have contacts on both ends of the bridge if I had power jumping over the door. And I could have just put it on one side and it would have been adequate. While we're at a pause, I do have my pictures up on my screen, but I know if I start trying to share my screen, something's going to go berserk and we're all going to end up watching a porno flick or something. So let's not do that.
We got to talk about the quality though. Okay, so let me try this. These were the ones that were in the email I missed.
Yeah, that's photos 1 through. Yeah,
yep.
Right.
There we go.
Oh, I'm sorry. We're where we wanted to be.
Right. These were the yep.
Okay, I'm falling asleep here.
It's okay.
Okay, going to starting with the photo in the upper left, you see this board that has the blue and yellow tape. That's not fixed in place yet. This clamp you see behind it is holding it in. But going back to the problem I'm being presented, you see how that board is pushing against a copper wire, which is representing bringing power from that end of the layout, the wall with the hole in it, to this point. And I'm saying to myself, I can't have an arrangement where when I start moving that bridge around, it starts knocking my contact 6 ways from Sunday. And I just wanted to see, okay, well, this is how it pushes against it here. And hopefully at the end of this, you guys may have some suggestions. One of the things that occurred to me looking at this particular photo is that I could take the piece of wood and move it back some. But I had in my mind as I was looking at this, the situation, Steve has a bridge on his that swings, Van Meter that is, and his bridge swings, but when it's put in place, he has literally the weight of the bridge itself for that, the movable contact to press against the stationary contact to get his electrical power across the bridge. I felt like, well, in this arrangement, you see the possible arrangement you see here, things are just kind of floating, and I don't have the benefit of the weight of the bridge pressing the two contacts together unless, come up with
why wouldn't you use a wire at this end of the bridge and just run it out, start here at the left, run it down along the wood towards the front, allow enough slack there for when it closes, and then have it run up to the bottom from the wood. So if you go back here and look, at this picture right here,
Yeah.
you got a wire that came from here to here, ran
Yeah.
along here, and then went from here to here. It would, when you close this, that wire would just compress down, use stranded wire.
Yeah.
And when you open this, it would just kind of open up around the corner. You could, run it here.
Oh, it could ride on the gate.
Yeah, exactly. I would just run the power to the bridge on the gate. And then that way, if you run the power around for the other side, then you have no contacts whatsoever.
Okay, that'll be the first
challenge
idea I ignore. Let's see if we can get some others.
Yeah, the challenge with contacts is keeping them in place. Yeah, no, it's good. Sorry.
That's okay. That's okay. I have real issues dealing with the obvious, but yes, that would sort of, and I may very well do that because the ideas I came up with, well, going back, okay, you took me back to the group. If you look at the photo that's on the lower right, you see the two contacts that I thought I would use for the other end of the bridge. Being concerned that, things weren't obstructed and got kicked out of the way when the bridge started moving around, I thought at the other end of the bridge, I would use sloping guides so that the bridge, as you lowered it down into place, it could only locate in one, it act as a register. The bridge would only be lowered into a single location. No foolishness here. And I figured, well, okay, if I have this permanent guides to guide into position, what I've done is, in that lower right photo, you can see that I've glued brass contacts bent in an angle around those guides. And that red and white wires you see are actually put into a hole and they're soldered to the brass contacts. I think they'll work and I think they'll be okay. And in the middle photo you see up high, you see a black contact with a white wire leading from it. Now, this is not the end where these contacts will go. They'll go on the other end. But if you imagine these on either side of this block of wood, when the bridge comes down, it locks into either side and my contact is good. Going to the idea that you mentioned, Phil, about running to get the wire, to get power into Winchester itself, if I go around the bridge, all of that is rendered moot. And, I don't have to worry of that after everything is all put together, these brass contacts don't stay in place. And I have to, call out the militia or something other to get that squared away. Well, I think I like that idea, Phil. And, that may very well be what I'm going to do. And since the power for this bridge, I have my layout divided into 4 power districts. And the power in the upper, in my staging layout that's overhead, that's power district number 1. And the bridge power will also be in the same district. So since I already have the power run around the top of the door to get to the other side of staging, I can just drop it down. Bada ba, bada boom, problem solved. I'm done.
I'm muted. That was good. That was good. So I guess to my perspective, contacts are, unless they're really necessary, are to be avoided. They tend to have problems. Cool. That was good. Jesse, so are you ready?
Hopefully I am. Let's see how this thing works. I hit share screen, yes?
Share screen, and then, and so the upper
You haven't
left,
enabled me.
oh, I haven't enabled you. I'm sorry. That's my fault. Yeah, the upper left is always your main screen, so that way we see what you see, which makes
Yeah,
it
got it
easier.
right there.
Yep.
No, right. Um,
And just click on it and click share. Upper left and share.
upper.
The upper left screen, which should be the screen that we're all on.
I see the screen that we're all on.
Yep, click
And then
on
the
that.
upper.
Click on that one.
Got
and
it.
and then click on share. There you go. It's sharing. And we're seeing the blue,
Okay,
your blue
great.
screen
And
now. And now your
there we
pictures are
are.
opening up. There they are. Excellent.
Okay, let's make this go away. And
There you go.
everybody see that okay?
Yep, we can, absolutely.
Okay, terrific. I built a gas station, and this is I was thumbing through the micro mark catalog, and they had something called scientific models. I've never built one of those, and essentially that's it. It's a little gas station. It's basically a box of laser cut wood with windows and doors and an empty interior. And I figured, okay, I got a space for that. And it gave me a chance to play with a lot of things that I haven't done together. So this is what it looks, the front of it looks like now versus what they think it was supposed to look like. And the gas pump, I didn't like the gas pumps, plus the fact I lost one. So the gas pump is J&L Innovations. The signs, almost all the signs on this thing are from the web that I downloaded. And the tire rack was somebody called Model Tech Studios, who I had never used before. They're sort of like Rusty Rail, and they were really good on office and shop details.
I'm sorry, but I'm going to,
Then going in the other direction on the other side, we've got the other view of the front, and there's been an accident and somebody knocked over one of the posts, and when he tried to glue it back together, it didn't glue well, so we took advantage of that. And since I lost one of the gas pumps, we replaced that with a scratch-built box, which is covering the hole where that gas pump would have been. This is a view of the back. Because of what I did inside, I figured we should have security on the back window, so I covered up the back window with strip wood, and this gives us the shop area now is more secure. This is the interior now. It basically was an empty box. On the right side is the shop area. On the left side is the office area. This is the office. Originally, they had basically sort of a wood framey wall. And what I did here was I added strip wood to the walls, so that covered over the make-believe 2x4s. And as you can see, the first major problem is that I have to go back and fix the window sills. They never got painted. These pieces are again the model. Oh, excuse me. These guys are the Model Tech Studios, and they had lots of good office equipment. The invoices and newspapers on the desk I made on my printer, and then made them littler and littler and littler and littler. I also need to work somewhat on the weathering. That's both on the floor, that's both chalk and India ink. Here's another view of the office area. And the door on the right side leading into the shop. And this is the shop area. The shop area, we've covered up the door, which wasn't there, with a little plywood up in the corner. The signs are, again, greatly reduced off the web. Most all of these pieces are rusty rail details. You probably recognize them. The shop. The figures I found on Woodland Scenics, they had a car, a van, and some figures. And so I purchased those, and those are what the figures in the car comes from. And then Woodland Scenic also had a group of derelict cars garage. And so up in the corner there, you'll see there's a pile of mufflers, and there's a couple of other detailed parts on the floor and that sort of stuff. Here's another view down again from of the shop area. I added a lot of internal bracing to the walls because as you can see possibly from here, this was all a clear span, and that would never pass any kind of building inspector. So I added some internal bracing here and there. And that's my story, and I'm sticking to it.
Cool.
Yeah.
Looks really nice.
Now, how do I get out of this thing?
I
There I
killed it.
am.
I killed it for you. There we go.
Oh, thank you very much.
Excellent. Well, that was good. That was very good. Do a we'll do a thumbs up here down in the reactions.
Thank you very much.
Okay. Anyone
Is,
else?
is that second worker just watching that guy that's being eaten by the car?
Actually, before he was turned around holding up the wall, and now he's supervising.
Oh, okay. Nobody's called
been-
911, right?
Yeah, no, the guy, I thought that was great being eaten by the car. If you've ever seen the models of buses that and things like that that come out of Latin America, where they always have these guys hanging inside the car or the truck. Usually it's a bus trying to get it to work. So I thought that was cool, have the car eat the guy.
Good. Okay, somebody's got to have something to share, or I'll have to share something. So come on, somebody. Okay.
All
Well,
right,
I'm-
I'm always a fool. I
Go
was
for
eating I was eating a donut here, Phil. So I'll turn my camera back on. Before everybody else came in, I was talking about my woes of building this helix. So can I share a couple pictures?
You certainly can.
You should be seeing a whole bunch of pictures of helixes.
Yep.
Okay, I'll blow this one up to give you an idea. You know, this is just a guard here. I went and I built the thing outside and drug it in. And I was sharing with the guys before that I'm trying to get this thing where the slope is the same. And I seem to be having an issue. And I'm not sure whether it's because I've gone high tech and bought a little digital measuring device or just not doing it right. And somebody brought up the idea that I'm using degrees versus slope on this digital device. Is that a possibility? Is there a difference?
Well, yeah, slope and degrees. Slope is a percentage, degrees is an angle. So 90 degrees is a 90-degree angle, but in terms of percent rise over run, that would be 100% rise over run. Actually, if, you know, it's actually at 45 is 100%. You can't even get to 90 degrees, I don't think, in the percentages.
Right.
Yeah,
But I'm
usually when you do a slope, when you do a helix or something like that, you know, you talk about, oh, I want a 2% rise or 2% slope or 3 or 4% slope, which is, as Phil says, you know, point A to point B, how high is one from the other?
So what you'd have to do is, if you're doing a 3% slope, that means for 100 inches horizontally, you go up 3 inches vertically. So if you put that into trigonometry, I think, if I remember, somebody correct me if I'm wrong, I think that's the sine. So if you do the sine of 3 over 100, you'll get the degrees of that angle. And it won't be 3 degrees. It'll be something else. I think it's...
you. That answers a lot of questions. Okay.
Yeah.
Because when I was buying this tool, I was like, okay, I should be able to measure this.
Yeah.
And I'm looking at John Allen and it's saying I should have like a 1.7% slope. And so I'm trying to put this as a 1.7 on this little digital gauge. And I learned early that I'm thinking, you know, something's wrong here. You know, I'm not sure whether it's the gauge, because last time I did it with a bubble level and a piece of wood, it went so smoothly, you know.
Yep.
So I'm thinking high tech.
Right.
Anybody have a good recommendation of a cheap slope measuring device?
Well, you've got it. You've got it. It's just a math calculation. So just all you need to do is do the sine of the slope you want, and that will give you the degrees you want.
Okay, sine of slope. All right,
I'll find. I tell you what, if you want, I'll find a simple little tool. There's got to be a little simple tool on the internet where you put in the sine.
No. It's tangent.
Is it tangent?
Sine.
Okay.
Yeah, because sine is opposite of a hypotenuse, and cosine is adjacent of a hypotenuse, and tangent is the two sides.
That's right. It's the two sides is the tangent. Even though so tangent.
You guys are freaking me out because remember last time I told you there was no intelligence allowed at this house. So
one other thing that, you know, I don't know anything about this, but it occurs to me that you want to be measuring your run circumference on the diameter. So you want to be measuring it as on the circumference, not a straight line from, you know, 10 inches center track to 10 inches, the straight line down the track.
Oh yeah. I mean, you know, I've got the John Allen book out, and when you look at it, 90 degrees at 30 inches is, what was it? It was 48 inches. Is that right? I don't know, something like that. I mean, I've got it. And so it's like 16 feet per circle. And I looked at his little chart and figured it out.
Mm-hmm.
And, you know, just like I did 20 years ago. And so I kind of narrowed it down to, it must be the device that's giving me problems.
Yeah.
No, it's your method, Jim.
Oh, I'm sure it's this.
This is the way I would approach it. I couldn't get my mic on there while you guys were talking. We had this problem building submarines. If you think about a submarine, it from the side view, it curves from front to back. And there's always an issue as to what is the curve at the location you're at to become parallel to the horizontal line that goes from bow to stern. And their solution was very simple. You decided what size level you would use. Typically, guys would use a 9-inch torpedo level. And then you could go to the shipwright shop and tell them I'm working between frames blank and blank. And they would say, okay, on such and such a ship, here is a block of wood that's 9 inches long or so, and it is cut to the slope that you want. And you use this block of wood and your 9-inch level, and you will always be parallel to the horizontal line through the sub.
Mhm.
And that's all you need is a block of wood with the slope that you want and a level that fits on that block of wood. And you could just go around your prehistoric helix.
And a multi-million-dollar wood shop that has, these are not guys that are doing it by eye, but they've got tools that I've seen that done, and it's magic how you could say, oh yeah, there's the thing, and here's the angle for 9 bits, that sort of stuff.
Like
Go,
in this
go,
picture, to-
circumference and go circumference.
to answer your question, Bob, there's my little torpedo level.
Then all you
And
need is a piece of wood cut with the slope on it.
I did find a piece of wood. There's no slope on it. I just put it at the same place every time. And it fits in there. And, you know, I'm using that. I'm going around. I'm going, this is what I did last time. And that thing worked good for 20 years. And, you know, then I threw in this little digital level that I bought and it all started to go to crap. So, you know,
Well,
I
it's
identified real quick that it must be something I'm doing with this digital level. And, you know, I spared no cost going to Amazon and buying one for 25 bucks, you know, so.
Well, at some point, I'm going to convince Phil to let me talk about the new types of helix that you and Cliff are ignoring, but the new type of helix where you just use a masonite spline, it is so easy. And all of this slope business, piece of absolute cake, and makes total sense to the unintelligent.
Yeah. But you can see I use this little hex cut. And, you know, so I started to doubt that. I thought, oh, my goodness, you know, this thing must be really, you know, wigged out. So, you know, I'm sitting out there, you know, you're getting hangry. You're getting, you know, it's like, my God, you know, what have I done wrong? But you can see where my issue is. I have this curved switch, which is going to come off of the helix and go to a second staging level. It will be on top of this. And what would happen is I would put a car up here after I dutifully started here and kept all the same angle, I guess we'll call it, you know, now that we know the right term. And it came around here and the angle was good. And then I would get here and all of a sudden the angle would go to 0. Okay, so I thought, okay, great. Maybe that the stupid thing's lying to me. So I put a car up here and it would, in fact, pick up speed. It would go around until right here and then it would slow down and stop. You know? So I did know that the angle was being true to me. It was showing the fact that it was zeroing out here. So the thing was lopsided. So the next attempt, I actually got it to the point where there was an upslope everywhere, but it's not even. So I'll be going back out there, giving it another shot today. So
I'll stop by this afternoon and give you my thoughts of.
Well, I think what I really need to do is go back to the little torpedo level on the piece of wood and use the digital device for figuring out when I have the saw blade at 90 degrees, once I've, you know, turned it somewhere else. You know, I tried to, I got wowed and, you know, I wanted to do all these things and, you know, so it just got to the point. Oh, there you go. Okay.
So this is using the tangent function in Excel. So these are degrees and this is the slope. The opposite function would have taken a little longer to figure out. So basically you can kind of see the variance. So if it shows 1 degree, it's 1.7% slope.
Yeah. So I have to be using this digital scale, trying to get it down to like 0.8.
Yeah. So you're going to be 0.8 to, you know, if you're going 2%, 1.5, 1.5, somewhere in there degrees.
Yeah. But I mean, I'd be trying to get this digital scale. It might depend on how I put my finger on it when I move it, you know, so that's how sensitive it is. So a really wrong tool for the job.
Yep.
I don't know, but that's my trials and tribulations. You know, I should get out there with a broom and sweep up the floor. The fun stuff is that I put this on L girder to support it. And that's working out really well until I realized that the easiest way to work with this helix is to get inside the damn thing. And of course, I wish I had video of that. You guys would be laughing. When I built my first one, it was no problem jumping in and out between these L girders and laying on the floor, crawling around in the dirt, holy crap. It took me about 5 good minutes to get under the L girder and to get up in the middle of this thing. And about 3 seconds to realize the piece of wood I needed was just out of reach. So another 5 minutes to crawl out of there and then realizing I'm never crawling back in there again. So, but trials and tribulations.
I always thought that idea of making your dispatcher station at the bottom of the helix was a great idea. I've seen that twice. There's one of the guys on the NMRA-X thing has that, and there's a guy up outside of Sacramento who has that, who is kind of the center of the helix is the dispatch station.
Yeah,
It's the same thing on Otis McGee's.
One of the guys in, who is it? Oh God, down by Monterey, wonderful railroad. But I don't know, that's my helix issue. So here I thought I was doing such a great job of getting this thing built and put in, and then it's like crap, it's not working. So, but anyway, any comments or whatever? So
Excellent.
I'll stop sharing. Maybe.
It's okay. I stopped it already.
Oh, good. All right.
Yeah. It turns out the host, by the way, I don't know if anybody noticed, if you go into full screen and you kind of watch different people, I actually finally got Zoom to upgrade this to a 720p account. It turns out the recording has always been 720p, but in most Zoom meetings, no one can transmit faster than 360. So when you send video, it's relatively low resolution, which looks fine when there are a bunch of us on the screen. But when you go to one person full screen, it gets pretty grainy. And when you're doing a demo, it gets really grainy. If you look now and you put it in full screen, depending on who's talking and how good their camera and their bandwidth is, you should actually get much better quality for showing things. So, but you have to go up to the view and go from gallery view to what's called speaker view to see that. So, okay, I'm going to share a screen here and show you guys something. That I'll show you kind of where I'm at on a couple of things. So I don't know if I think I've shown this. This is my this is a 3D printed framed building I've built. And so these were actually some earlier pictures of it assembled. And so what I wanted to do was actually stop sharing that. And what I want to show you is kind of where I'm at, because I'm just about to the point of assembly. So this is one of the walls. So I don't know. Oh, hang on. Let me turn off my, you always have to remember to turn off your virtual background. So I don't know, can you guys see that very well? It's pretty close, but you can see, so like there are hangers on there. Those black things are hangers for the wires to run, because the way this works is that there are these trusses. And so the trusses, this is a truss, and the truss has the lights on it. And they're designed to sit into the wall, and then the wires are going to run on these little points right here along the top of the wall to one place where they come together. So I don't know if that's kind of obvious, but I'm kind of happy with how these came out. So those are 3D printed and then wood grained, and then actually have on them the, actually here, let me do this. I'm not doing the right thing here that I'm supposed to do. I'm supposed to spotlight that. And so you can actually see, and the gussets are actually also 3D printed as separate little objects. And so what's interesting is if you see on the end of this end, it's painted, and this is actually the office that's going to go in there as an assembly. And so it'll sit kind of in the corner, and you'll be able to see into it from outside with windows. But again, that's, all 3D printed then with strip wood on it. And I think it came out pretty well, the kind of coloring and wood grain matching. And then kind of the last thing I want to show you is this. This is, so I had this sitting kind of half put together. I'd printed it, and I decided that if I was going to put sheathing on it, I had the joists too close together, and the only way it would work is if you didn't use sheathing. So I decided, since I had to reprint it, I'd go ahead and put it together and see. So I think I'm just going to basically finish this. So I don't know, you can see how large that is. Go ahead and finish it with, and paint it and finish it, and then just put aluminum siding on it directly. And just have to, it basically lifts off. If you look on this side, it's designed, it's got these, the gussets to support it. And then you can see right here at the end, there are little clips that are designed to hold it in place when you put it on the roof. So anyway, so that's kind of been my one project I've been focused on over the last couple of weeks. So kind of coming together.
When you say you printed it again, Phil, are you doing this at home?
Yeah, no, I printed this at home. It's printed actually as six. It's actually more than that. It's actually 8 pieces. So this piece right here, where these joints are, this is one piece here, and that'll fit on the print bread. This is another piece. This is a piece here. This is a piece here, and these two are pieces. And then these are all epoxied together. And actually, there's pins in here. In these gussets, there are pins in the middle to hold everything together. But it's actually, pretty amazingly solid. For, it's only 3 millimeters thick. So.
Well, I was looking at it and I can't see it as close as you can, but I was thinking, God, did he glue all of these pieces together?
No,
they're sections. It's like,
yeah, no,
okay.
it prints. In fact, I may have, hang on, let me look and see. Trying to see if I had a copy in here of a print of it. No, I don't have pieces. I don't have any pictures of pieces of it here. I think I have them somewhere, but not where I am now.
Well, that was more or less just a comment from somebody who doesn't understand 3D printing. So,
yeah, the beauty of 3D printing is everything's just an individual object in the print file.
Yeah, don't roll back too far, Phil. Your dog's right behind you.
Oh, she's back a little ways. Yeah, she's the little golden. She's yeah.
well, this is where I do a dig. I know Bob Moore was listening intently to that 3D printing thing. Can you 3D print a gate, Bob?
I was just getting ready to ask Phil about that of his.
So this is kind of the best picture I have that shows. So you can see where these clamps are. Right here, there's a brake line. And you can see right here, there's a brake line where those clamps are. So this piece right here was printed as a single print piece. And it was printed with the side that's towards us on the print bed. And so basically what you're basically doing is you're designing kind of building pieces in CAD, kind of like they are in a regular building, except they're not really designed that way. They're designed just to all print together. So, and then if you guys,
do you have to be some sort of librarian to keep track of all these sections while they're in the computer before there's something physical you can hold?
So what you do is, basically the whole thing with 3D printing is, and Fran understands this better than I do. He's done a lot more of this than I have, is you basically are designing something, in the 3D application, in, whatever graphics application you've got, whether you're using Fusion or FreeCAD or Tinkercad, and you're designing it, and then the printer is printing plastic where you designed it. I mean, the interesting thing is it's really no different than drawing on a piece of paper. If you use a program like PowerPoint to draw on a piece of paper, you're drawing in 2 dimensions. The thing to think about with 3D printing, you're just drawing in 3 dimensions. So the tools just let you draw in a 3rd dimension, and wherever you put in something that's solid, it'll print solid material. So basically, if you think about it, if you think about a bed, and if I want to put a wall on the bed, I actually printed this, which let me spotlight myself so you guys can see this. I printed this just as a test. So this is that's actually an HO wall, frame wall printed on a resin printer. or not a resin printer, on a filament printer. So, but if you think about this, if you think about designing this, this is flat like this. Each one of these studs is basically just a little piece. And it turns out what makes it really easy when you design it is you do the first one, and then you just copy it, and you just index the distance it moves for each one. So making 10 studs is really easy, because what you do is you design the first one, which is basically, you lay it down as a square, and then you extrude it up to make a 2x4. And then what you do is you take that 2x4, which now is a distance off of a point, and you copy it and you move it another 16 inches farther to the left, and that's the next stud. And then you copy that one and move it 16 inches more, and that's the next one. And so you can build a wall like this in the design applications real fast, because you're basically just laying these pieces in, and as long as they all touch, it just molds them all together into a completed thing.
Do you put texture on it, or is it all flat?
So what I did with these was I printed these with this side down on the print bed, which means that this side, which I knew was going to get the wood on it, was the side that kind of had more grain. So this side was more flat. And then what I do is I sprayed this with 3 coats of automotive, they call it filling primer. And it's basically and then that actually gave me enough. You really can't see it, but there's actually wood grain. So what I did then was I used a side of a saw, a jeweler's saw against it, and just rubbed along here and created wood grain. It's see if you can see it in this one. I don't know if you can get. I don't know. Hang on, let me spotlight myself again. That way you can see it. So I don't know. Can you see? Can you see the wood grain in that? I don't know if you can see down along it there. You just can't, I don't think the camera's sharp enough to see it.
You just have to hold it still so it'll focus on that corner.
Yeah.
Yeah, it won't focus that
Yeah,
close.
it won't focus. I'm too big behind it, I think. So it gives a little bit of wood grain. It's not great. It's not real heavy, but it's actually not bad. It gives it a little bit of shape, and it doesn't look, I mean, I'm actually pretty happy with, if you look at this one, kind of the color combination, that you can't tell the difference between the plastic printed frame and the wood, which was actually stained. So came out pretty well. Took a bunch of steps to finally get that to work.
If you want, I could share a Tinkercad, some windows that I designed to be printed.
Go for it. Go for it. Sharing's open.
Okay, share screen and do that.
And
So
Phil,
there-
what scale is that?
It's it's for an ON30 module.
So hopefully you can see my desktop.
Yep.
Yep. Okay. So this is just, Grant Line makes wonderful stuff, but I'm making a mill and they didn't have the size windows and doors that I wanted. And so in Tinkercad, I just built out, here's my window frame, here's my door, here's a warehouse door, a larger door that I'm building for it. And all this is it's a collection of, shapes that I just, boxes. You take a box and, size it to whatever you want. And then you can combine them into, bigger, more complex shapes. And that's all I did to create these windows and doors. And then I put doorknobs on them and I just 3D printed them. And now I have perfect windows and doors that match the scale that I was looking for.
And those are an HO, right?
This is actually S scale. I
S,
was working
okay.
in S. Yeah.
Yep.
Yeah. And so all it is just a collection of, rectangles that I merged together. If I, take the window frame and ungroup it, you'll see it's like just different pieces. This is a piece to remove. So there's like the grain patterns and stuff. So I actually did little pieces with, removing stuff, build a box and then remove lines to give it more texture. And like there's these here are just all the little, pieces of wood. So it's built up like you would build a real window.
Right.
You know, and so each of these pieces are the dimensions of a scale appropriate piece of wood. And I just kind of manually built them together like you would a window.
I wish it was that easy in real life.
Yes.
When do you drive the nails in there? Yeah.
That's the nice part. There's no nailing.
Well, kind of the scary thing is it's getting that easy. You know, they're actually doing and getting better at 3D printing with concrete. So you actually can 3D print a building.
Yeah, I watched a video of some company that's 3D printing homes in South Africa for, the underprivileged. And they can go in, once they get like the spot cleared, within a day, they can build 2 or 3 homes.
Yep.
So Phil, is that your printer behind you there?
On the floor, the lower one there on the left. Yeah.
Lower
Yeah.
right?
Yep. Down here. Yes.
Okay.
It was an Epson. I bought an Epson because the cost of the ink is so much lower in the Epson. You get bottles of ink and you pour it in, and it seems to be much less expensive than what we were experiencing with an HP.
Yeah, and I guess I'm not going to go into a cost analysis here, but what is, that gets set up in this thing? How much are we talking here? We talking hundreds or thousands?
For the 3D printer. No, that's not the 3D printer. That's an Epson printer.
Yeah.
No, my 3D printer is not. So there are two. So one of the things to do is watch the video that's up on the website on YouTube that Jonathan did on 3D printing, because there are 2 kinds of 3D printing. There's what I bought, which is a filament printer, which is great for printing this kind of stuff. And then there's a second kind of printer, which is a resin printer, which is what you want for details. So like the windows that Jonathan showed you that he designed and he said he printed those on a resin printer. They wouldn't print effectively on a filament printer. And Jonathan, feel free to correct me if I'm wrong.
Yeah, no, yeah, you're spot on. So I actually have both. I have a resin printer and a filament printer. And so for larger structures and cases and stuff like that, I use the filament printer. But for the detail parts, the windows, the doors, inside, like I do my own filing cabinets and desks and stuff like that, I use the resin printer for that.
Yeah, but I mean, still, are we talking major cash input, or are we talking?
So I bought the one I bought is called, from a company called Ender. It's called an Ender Pro 3. And it was $180. And I bought a kilogram of filament when I bought it, and the total bill was $212 delivered, I think. And I've gone through, I bought 2 more kilograms I bought gray originally, and then I bought black and blue. And I've gone through about half the black and about a third of the blue. And I'm actually on my second gray. And that's because basically you end up printing everything at least twice. Because
if you're lucky, you only twice.
Yeah, at least. I said it. Yeah, at least. I mean, I have here, I'm sure Jonathan has a picture like this, but I'll share a picture for a moment. Enjoy. This is, so that's just that's the pile of everything I printed to print that building that I threw away. And you can see all the shapes in there. So this is like a wall. If you look at the wall that I held up, you can see these are pieces that come out of those walls. And as I went through the designs, I've got a whole bag of stuff I've thrown away. So, but once you get that point, kind of the maintenance doesn't seem too bad on the filament ones. I think the resin ones are a lot higher.
Maintenance on it isn't higher, but printing, it's a lot more finicky of printing. But so you can pick up the resin printer I picked up, I spent about $160 on. And then, the resin cost is about the same as a spool of filament. And so they're comparable. The filament printer I have is a higher end one that does really nice quality prints, and it's like, it was $700 as a kit, and then I put it together.
Cool.
One of the problems is that you need to have some place to put the printer that is like a garage or some sort of space that's not part of the house, so that you can have the various vapors and things, and you can just let it sit there and print for hours on some of these layer type things.
So for the resin printer, absolutely. I actually moved my resin printer into the garage. I built an enclosure for it, and it's sitting in the garage, and it actually vents outside because working with the resins is very toxic. My filament printer, because 99% I print is PLA, which is really, you know, not that bad, that I have inside an enclosure in my hobby room.
Yeah, the problem is those of us that are in apartment life don't really have that option.
So
There-
actually, mine is in the game room, which is kind of, I'm turning into a train room, and I've run it for a pretty long time. So like those roof panels, each one was about a 3 to 4 hour print, and I've never noticed any smells or anything from it.
Okay,
But it's just PLA. I mean, I've been assured by a couple of folks. I think Bob assured me that if I did ABS, I would regret it.
Yes,
Wow.
I've printed ABS and even PETG in my filament printer, and it's a little stinky. But yeah, the PLA is
yeah.
fine.
I'm just getting back to the point that this is another one like airbrushing that I've had to forego because I live in an apartment style building.
Got to get a booth and an exhaust though for the airbrushing.
I
Yeah,
have
but I mean-
no place to put an exhaust fume to go out the house. I can't cut holes in the wall.
Yeah. I guess through a window. I was thinking you could do something where you put something in a window and
Yeah, the way my windows are structured, it doesn't work.
Ah.
What I do with I do use some spray painting, but what it is, I have to go out on the deck and between gusts of wind. I can get maybe a can, get a couple of shots off.
So Steve is showing something on his iPad. I think he's showing something.
Yeah, it's nothing as sophisticated as all you guys are doing. But over the last 30 years or so, I've collected Brock Candy Factory kits from Walthers in hopes that someday I would build a quasi Montgomery Ward for the WP part of my layout. This is only a 6-story building. The real one's 8. And I'm just spinning it. I'm up here in the kitchen spinning this around on the, it's in the process of being built. So I thought I'd just show you. It's a kit bash.
Cool.
Using Dremel tool and saw. And I got a ways to go yet on it, but it'll provide, let's see, I'll spin it around here. A place for 2 tracks to come in, set a boxcar in each one and provide a little bit of operation on the Oakland end of the WP. So that's what I'm working on.
Cool.
So Steve, are you going to use frosted windows or are you going to fully detail the inside of that thing?
No way I'm going to detail. I'm the opposite of Jesse. I'm just good enough. I'm having trouble with the windows. They're all, not trouble, but I'm using marker to do the panes. They're raised on clear plastic. And so I put on some music and sit there in front of that. So making the glass panes, but this is not laser print or anything that's old fashioned.
I have one thing I'm working on this morning, and I'll just bring it up here so you can see it. It's a bollard. It's put in parts around the station to keep people from driving onto the platform.
But is it operable? Is it going to be operable, come up and down?
Oh, no. The SP was not into the high tech. These actually go
Okay.
back into the 40s. They put these up around my Port Costa station in places they didn't want people to drive. It's guys that
Can you
drive
hold that
over
up
the
again,
tracks.
Ken?
Huh?
Can you hold that up again? Because it was kind of off to the side.
I'm sorry. Still?
Can you hold that up again? Because
Oh,
it was
yeah,
off to
here.
the, there you go.
I'm holding it up again. Whoops. I've got to do this. It's just nothing more than a square piece of evergreen plastic stuck through another piece of plastic, and I stick them in the ground. Here. But the thing is just to make sure that they're, there we are. Doesn't like to do close-ups. But you'll find them in pictures of stations. You find them all over the place. Where particularly where there's a slope that I have on my layout, where you drive a slope up to the level of the station platform, and there was a walkway there that was quite narrow, and they didn't want people driving.
Yeah, I know there are a lot of those now that are actually automated where they go up and down. That's they're trying to figure.
Yeah.
The round ones, the
Yeah.
bollards, seems to be popular in the UK.
Yeah, no, it's this is actually that may even go back to the 30s. Particularly the area around the station in Port Costa, there was a large section house nearby or right next to it, and the guys, the workers had come home drunk. They drive into the weirdest spots. They had to put these things up to keep them from driving into the turntable pit and into onto the platforms.
Cool.
Just a little detail. That's all.
No, it is. Those are the things that make things look more realistic. Those details.
Yeah. One of the things, and I'll get into this, I'm going to do a presentation for you eventually when I get all the stuff together. But in the concept of modeling Port Costa and going through a lot of pictures, trying to grab every picture I can from any place, and learn the details of how the engine facility and station and everything else worked. In the context of it, and I like Port Costa. I used to go to the Bull Valley Inn before pandemic, which was a great restaurant and bar. And that's right across the street from where the station was.
This is a small, about a 12-foot flat car, 3D printed in, so far four parts, a main frame, two side frames, and a deck which will go on. It can also just be planked with, I'll probably just be planking them with basswood or something. But the wheels, this is ON 18, and the wheels are 3D printed from Shapeways, but everything else is 3D printed on a filament printer, as well as stake sides to make it to make it a gondola whenever, if we want to do that. These 3D printed wheels are, they're an ABS type material, and I really don't know yet how well they'll actually function, how well they'll run. The detail on them is really fine. This is how you get them in a string of where they're really floating inside this piece of chain. So you just cut the chain. There we go. You just cut the chain to get each wheel out. You see each wheel is floating in there.
That's a whole new gift of a string of pearls to give to your better half for Christmas or Valentine's Day. They look brilliant.
Yeah, these do really look good. And I will report back when I get them on some ON18 track and give them a good work in. But other than that, these wheels here are metal. They're, just like a KD or a Walters wheel. They're solid. They're not spoke. And these are from Greenwich in the UK.
Greenwich, okay.
Yeah, and they seem like pretty quality wheels. The thing is, their axle length, axle width, whatever, is more of a real end scale. So you see, your side frames have to be really close. You're really tight with getting the wheel in there, and the profile of it for ON18, maybe this will work better. It's kind of tight, whereas you look at these wheels from Shapeways, you have a lot. It just looks a little more to prototype as far as the spacing between the center frames, I think, from what my eye gives.
Mhm.
And these Shapeway wheels, they came out to like about $1 each in a strip of 20, and they're nicely spoke.
So Fran, you gave them one design part and said you wanted 20, and they did the string of pearls thing. You didn't have to do that.
Actually, no. I didn't even. I did not design the wheels. They're available on the Shapeways marketplace.
Oh, okay.
Yeah. So a guy does them, and he's got a whole lot of experience at it, and I'm figuring, being as he's selling them and he doesn't have bad reviews, maybe they work.
Cool.
Maybe their qualities is close to the metal ones. Other than that, there's this is a O scale it's actually only about a 7 foot ladder, O scale. It's about 1 millimeter thick, and that's I'm doing that on a printer like yours, Phil, on an Ender 3, and as long as I put these little flat, these 0.2 millimeter flat pieces down first, and then print over them, then the thing stays on the print bed. And otherwise, printing something that thin, you have so little surface contact that often before you're done printing, the thing is peeling up from the print bed. So these are similar to what the printing world would call brims, only they don't go all the way around it. They're spot brims to hold the piece down in places where it's liable to lift, like at the end of the ladder, just that little 1 millimeter wide stick.
Yeah, that was something I found when I did these. If you had things just coming out at the ends here like this, and they weren't squared off, they didn't stick very well. They tended to pull up. Yeah, it's I actually had the first time where I had a major adhesion issue, and it was actually on a big part that shouldn't have had it. But what had happened was the room had gotten down into the low 60s. It was very cold. and the temperature, I found, I bought one of those Costco heaters that's a dish thing, and I use it in my shop, and I use it, I put it for an hour into my spray booth in the garage to warm it up before I paint. I put it on the printer for an hour and it solved the problem. I just let it sit on a chair and just heat the printer and everything around it up for a while. And then things got better. But yeah,
that was something I dealt a lot of issues with, was adhesion, and I ended up built a little case, a simple little case for my 3D printer. And if I want to warm it up, I just turn the heat plate on for a little while, and I actually run the chamber at about 100 degrees Fahrenheit, and then I never have adhesion problems.
Well, I'm sorry, gentlemen, but it's time to go for me. I've got another Zoom session coming up on hindsight. Okay?
well, and actually that's true. There's an 11 o'clock session. I don't know. I've got to go see if they got, but there's an 11 o'clock Redwood Divisions session coming up, I believe, today.
Yeah. Okay. All right.
Have a good one, Ken.
See you later.
So I had one other thing I was going to share. This is not a modeling project. This was a purchase. So I bought a package of these. 602s are the really small ones. Wow. Zoom. System.
You're still on.
It looks like Phil's crashed his Zoom.
Yeah, that was weird. It was, when I shared, it was like it decided it didn't like my sharing. But anyway, I'll put that up there. That was, let me see. I can share it again.
And you're using those LEDs in the little drop down green lights?
So those green lights actually were ones I bought that had a shade on them. These, I bought these primarily because I thought they were really interesting. I'm actually going to try to use them to do illuminated marker lights on an O-scale fishing boat by taking a bead and putting them inside of a bead and then drilling back through the wall. But they are really tiny. And they come with resistors for 12 volts, 5 volts, and 3 volts. So they actually have 3 sets of resistors with them. And what's amazing, so this is 25 was $10. And if you want to go for 100, it's 30. So, it's an amazing number of LEDs you could put into a structure or something.
Yeah, I've been using those to light my structures, and actually I have a brass goose. I do RGS, and so I got my hands on a goose, and I actually use these LEDs for the marker lights, and they're just so small and so easy to work with. I love them. And you can't beat the price.
Hang on, somebody asked a question about the 3D printing. Let me put that up. So I'll put up the channel. This is our YouTube channel. I'll put that in the chat. And all the videos are up there. I haven't put up ones from last time. I shirked my responsibility. And if I go into videos, and I'll put, this is Jonathan's clinic on the last link in the 3 links that I put up. The first one is the lights. The second one is the YouTube channel where all the videos are. And the last one is Jonathan's clinic video. So cool. Well, I think we're probably at the end of everybody sharing, unless someone else has something else to share.
Well, I just want to say thanks for straightening me out on the tools there.
That's good. That's good. That's why
Now I'm a little more motivated to get out there and fix it. So
that's why we have these. That's why we have these meetings, right? Is to get everybody to figure out what we're doing. It's you know, it's amazing how many times you do something, you just you don't actually think about what's the obvious thing to do. So I had one last thing I'll share. This is not a modeling thing, but we may find this interesting. So we had to take the car yesterday to get it fixed, and we were ended up coming back on, this is on Stanley Boulevard heading towards Livermore. And I didn't put any sound on, so the sound is just in the car because the doors were closed, windows were closed. So yeah, this was 5 engines pulling a block of cars out of here going somewhere. And you'll see in a moment, all the cars that are parked on Stanley will show up here. They generally park a string of container cars, or in this case, I think they're trailer flats. And so it would see all the engines sitting out in Livermore, or out in Tracy. You begin to wonder. So there are the cars that are parked there. So I thought that might be kind of an interesting view for the day. So close with that. Unless anyone has anything else. So we'll see everybody in 2 weeks on the 20th. Have a great couple of weeks and enjoy.
Yeah.
Bye, everybody.
Bye.
Have a good one.